attributes is empty, then we just return the single node of the tree with the label set equal to the most common value, the target attribute in the examples. Let me pause for a second here and go through some of the output. Okay, so we've generated the overall information gain for each of the attributes. And what all information gain is, so when we talk about something like an entropy, that's the level of uncertainty of the decision that we should make on a given attribute. The information gain is what we're trying to maximize. We're going to pick the highest of these three values. That's the difference between the uncertainty values that we generated for each node. So basically, we go through the entire tree until we've covered all of the nodes, and then we finally can zero out those. You can't see the last line. It'll say we finally reached 0 and we've covered all the nodes. And we can see that the model accuracy is 50. That's okay. It's not 95% accuracy as you use in a valid use case or something like that.
Can you show that one more time, the GUI?
Sure. That's about it.
So basically, you use 75% of the data to build the tree, right?
Correct.
Train the classifier.
Yes.
The other 25% then would be used to test the accuracy, and that's why you get 50%, right?
All right. Any questions about the code, about the ID3 algorithm in general? It's okay. Come on.
So there's no actual tree.
There's no representation that you can visually see. I mean, it's here in the output as it's running through the logic. There's no actual, the GUI doesn't actually show a nice graphical tree, but I can show you a little bit more if you want. So if I go in here to the data node, you can actually see an example of how it's structured. So you can see here, we know whether or not it's leaf. We have the actual node data stored as an array list. The attributes, also an array list, the children of that node, the degree of uncertainty, and as well as how we need to split that node. So the overall goal is to decide how we're going to split to maximize the level of gain value that we learn from minimizing the difference, or rather, between the entropy of the different nodes in the tree.
Yes.
Yes.
When you said it builds the root node and then it checks if something's positive or negative, what were you saying it checks for positive and negative? What is that value?
Those are here in the actual inputted data set that we have here. So it's actually given, so it decides whether or not it's going to be so those are the decisions, right? It's either positive or it's negative, and we can correlate that when we're actually aggregating over our data to form the tree. So it actually references that to make its decision.
Other questions? Okay. Let's applaud the presenters then.